A very good morning to you all children. Our last lesson we discussed about the atoms and molecules. Today we are going to learn lesson 11, that is work and energy. You have learnt about the terms work and energy, right? In your previous classes, in your previous standards. So let us know what is work and what is energy. When can you say that work is said to be done? Work is said to be done when an applied force produces a displacement in the body in its own direction. Children, for exams, you might have worked a lot. You sat in one place and you might have prepared for your exams. Can you say that you have done work? Yes? No. It is nothing but when a force is applied on an object and that applied force produces a displacement in the body in its own direction, then only we can say that work is done. For example, when you are trying to push a tree or push a big rock or push a wall, you keep on pushing it, but will the rock move? Or will the wall move? No, definitely not. So you might have become tired by doing that work. But according to science, when can you say that work is done? So work is said to be done when an applied force produces a displacement. Displacement means movement in the object. So when you are applying a force on an object and that object is getting displaced in its own direction, then only we can say that work is done. So work W is represented as the product of force and displacement. So symbolically you write it as W is equal to F into S. And this work done is a scalar quantity. Okay. And its SI unit is joules. The unit of work is joules. And in CGS units, that is SI unit is joules. The CGS unit you call it as erg. And 1 joule is nothing but 10 power 7 ergs. And 1 kilojoule is nothing but 10 power 3 ergs. Okay children. So coming to what is a joule, and when can we say that the work done is positive and when can we say that the work done is negative? So what is joule? Joule is nothing but work done is said to be 1 joule if force of 1 Newton displaces a body by 1 meter. Work done is 1 joule if force of 1 Newton displaces a body by 1 meter, because W is equal to F into S and unit of force is Newton. So when force of 1 Newton is displacing a body of 1 meter, distance is 1 meter in its own direction, then you can say that the work done is equal to 1 joule. What are the conditions required for work to be done? So what are the conditions? The first one is a non-zero force is applied. Means the force has to be applied. Force must not be equal to 0. And because of that force, the body has to get displaced. So these are the two conditions. That is, a non-zero force has to be applied and the body has to get displaced. Then only we can say that work is done. Okay. And when can you say work done is positive? Work done is positive when the force is in the direction of displacement. So we take the work done W as positive when the force is in the direction of displacement, and it is negative when the force acts in the opposite direction of displacement. So when force is applied and the object has displaced in the opposite direction, then you say that work done is negative, and force is applied, the displacement is in the same direction, then we can say that work done is positive. Okay children, so here are some pictures which show the work is done. So in the first picture, we can see a man sitting and working on a laptop. So can you say the work is done? Maybe he might have spent some hours to do that work. He may feel tired, but work is not done because there is no displacement in the object. In the second picture, you can see force is applied and the object is moved. It has traveled, it has got displaced, and even we can say that it is also positive because the object is moving or displaced in the same direction of applied force. So work is done when force is applied and that applied force displaces the object. If the force is applied and displacement is in the same direction, then we can say that the work done is positive. When it is in the opposite direction, we say that the work done is negative. So here in this picture, you can see that a man is just standing with the suitcase. So you cannot say that work is done. The second situation, a man is walking holding the suitcase. So you can say that work is done. Okay children. So coming to the energy. What is energy? And you are going to know about its forms. So energy is nothing but the capacity or the ability to do work. Okay, the ability or the capacity to do work is called as energy, and the unit of this energy is same as that of the work, that is joule. So work is joule and even energy is also joule. Sometimes we use the larger unit, that is kilojoules. So 1 kilojoule is equal to 1000 joules. Okay children, so this is about the energy, and we all know that there are different forms of energy like heat energy, light energy, chemical, sound, tidal, mechanical, geothermal, electrical. There are many forms of energy children. In this lesson, we are going to learn especially about the mechanical energy. So this mechanical energy is again divided into two types, that is potential energy and kinetic energy. So what do you mean by kinetic energy? Kinetic energy is nothing but the energy possessed by a body due to its motion or movement. The energy possessed by a body due to its motion or movement, then it is called as kinetic energy. The energy is said to be kinetic. And when can you say that the energy is potential? The energy possessed by a body due to its position. Okay, so any object which is at rest also possesses energy. That type of energy is nothing but called as potential. So energy possessed by a body by virtue of its motion is called as kinetic energy, and energy possessed by a body due to its position is called as potential energy. So kinetic energy of an object increases with its speed. Kinetic energy increases with its speed. Some of the examples of kinetic energy are the moving bullet. Okay, so moving a bullet which is fired from a gun, it will increase, the kinetic energy will increase with its speed. The speed also will, when the speed increases, the kinetic energy also increases. So moving bullet, a falling coconut, a rotating wheel, a rolling stone, a flying aircraft, a running athlete, flowing water, etc. So here you can see the pictures of the flowing water which is falling from a mountain, a flying aircraft, and even the windmill, the wind vane which is rotating by the in the direction of the wind with the help of the wind. So all these are the examples of kinetic energy. Now coming to potential energy, a stretched rubber band, okay, then water stored in a dam, a book lying on a table, a raised hammer, a bag of wheat or the rice placed in some position. So all these are the examples of potential, that is energy possessed by an object by virtue of its position. So here you can see the pictures of a water which is stored in a dam. The right side at the top you can see a flowing water which possesses a kinetic energy, a camera which is placed on that, and rubber bands which are present. So all these are the examples which possess the potential energy.